Hello students, how are you all? From last lecture, we are talking about the factors affecting the climate. Okay, so as you know very well, in last lecture which we discussed about that there are six factors which affect the climate. Okay, so I hope you have learnt them by heart or you have understood them, isn't it? Chalo, fine. Let me revise it again once for you. First, it is latitude, altitude, then pressure and wind system that we are going to study now in details, okay, and relief feature, then distance from the sea which is called continentality, okay, and sixth one, remind me afterwards, okay, you will remind me now. I am not getting it what exactly it is. Okay, let me show you what's the problem in that. Okay, so the sixth is ocean currents, yeah. Okay, so these six factors they affect the India's climate. Okay, now we are talking in details about pressure and wind system. Okay, for this topic we are going to give a special lecture, okay, because there are many key concepts in this that we have to understand first. The climate and associated weather conditions in India are governed by the following atmospheric conditions, that is pressure and surface winds, upper air circulation, and western cyclonic disturbances and tropical cyclones. Okay, so to understand this, let's go by let's go one by one key concept. So first of all, we'll understand western cyclonic disturbance. What exactly it is? Okay, so as you know that what are western disturbances? Okay, western disturbances, the storms that bring rain and wrap the Himalayas in snow every year. Okay, so here you can see, yeah, uh, the storms that bring rain and drape the Himalayas in snow every winter visit India from far off lands. Okay, they come from the western areas. Okay, so when they come to India, they are stopped or they are faced by Himalayas first. Okay, so here you will understand it. See this map. Okay, this is Mediterranean Sea, and if we start moving from here one by one from Europe, we will come to Central Asia, and from Central Asia, right side will go to India. Okay, then one thing you will understand that while understanding this, they originate in Mediterranean Sea. What? These western cyclonic disturbances. In Mediterranean Sea, there is a high pressure. Okay, and if you start from here and you will go to right side, then there is India. Okay, so in Indian era at that time, it is a low pressure. So from this high pressure to low pressure, these originated cyclonic disturbances, they start their journey and they move from this place towards India. Okay, now they originate in the Mediterranean, parts of the Europe and Atlantic Ocean. Okay, then you can see here the winds get disturbed by low pressure areas and come from a westward direction with respect to India. Okay, so when they are coming to us, they are coming from western side. That's why they are called western cyclonic disturbances. Okay, then that's how western disturbance got its name that I told you now. See, this the storm travels towards the Afghanistan from that Mediterranean Sea, okay, Pakistan and India along with high altitude. Then along their way, they pick up the moisture, Mediterranean Sea, Caspian Sea, Arabian Sea, and they bring it to Himalayas and shed the rain and snow on the Himalayas. Then usually they move the northern mountain stages. There they fall completely. Okay, and you know very well that when they come, their arrival is not that much good for us. They bring such a disaster for us. So the western cyclonic disturbances, you can see in 2013, Uttarakhand disaster was there, which caused the death of over 5,000 people just because of these cyclonic disturbances. It was a result of an anomalous western disturbance. Okay, so now we will understand how the cyclones are formed. You can see there are three stages of cyclones: origin, then it is a mature state, and then spreading away, that is dissipation. Okay, so when they start moving in this way, they move here and there. The reasons, the factors responsible for this is Coriolis force also. Okay, so they don't move in one direction, as you can see how they are moving. Okay, so in spherical shape they keep moving from one place to another place. Okay, they get the power from the water, again from land. As they are moving on the land, they are weaker, again they come back to the ocean, they get stronger, and again they move. Okay, so which conditions are required for the cyclones to be formed? It should be large, still warm ocean area with temperature above 26.5 degree. Then this see, when there is a heat, because of that heat, the air which is light, it just grows up. Okay, and as it is growing up, it creates a cloud. Low latitude winds blowing from different directions. Okay, so when they come together, they form thick cloud, which afterwards is going to get converted into the cyclone. Okay, so here you can see how it is developing. Clouds form and rise to 10 kilometer in the troposphere. Okay, how you can see how they are getting formed. Okay, then energy is released from here. So this is the eye of the cyclone. We can see epicenter of the cyclone, from where it is getting energy, and as it creates the spherical movement, so it gives shape. Here you can see, and because of this spherical movement, the cyclones, they are moving in spherical way. Okay, so the clouds, they grow 12 to 15 kilometer high. Such a wonderful thing it is. Okay, and below, because of this Coriolis effect, what Coriolis effect is, that I will tell you afterwards. Because of Coriolis effect, they start moving from one place to another. Okay, and in mature state they look like this. Okay, so here you can see they are getting energy from here. Okay, and here they are just dropping out. See this white. Okay, so in this way cyclones are formed. This is the eye of the storm you can see here. Okay, then southern hemisphere, clockwise it moves, and if you go to northern hemisphere, it is anti-clockwise, the movement of the cyclone. Why so? Because of Coriolis force. Clear? So here you can see the power of this cyclones. So in this way cyclones are formed, and they start moving, or they keep moving from one place to another place. So these cyclones, many times they come to us from Mediterranean Sea, but because of our protector, that is the Himalaya, they stopped there, and because of that we experience very mild winter. If just imagine there is no Himalayas, then such kind of western disturbances might be regular activity in India, and as you know very well how big damage it causes. India lies in the region of northeasterly winds. Easterly winds means which comes from the east side. Okay, these winds originate from the subtropical high pressure belt of the northern hemisphere. Subtropical, above Tropic of Cancer. Okay, that area is called subtropical. So high pressure belt of the northern hemisphere, there is a high pressure. As you will go above Tropic of Cancer, subtropical area will start. So as this area is cold, it is high in pressure. But if you go to equator, it is receiving maximum sunlight. That's why it is having low pressure, and the air from the low pressure, it is warm, and the air from high pressure, it is cold. These easterly winds, they blow southwards, get deflected to the right due to the Coriolis force and move towards the equatorial low pressure area. Okay. Generally, these winds carry little moisture as they originate and blow over land. Therefore, they bring little or no rain. Okay. How so? Let's try to understand. Just imagine. Means in India, in summer season, there is so much heat. That's why there is a upsurge of the air which is warm. So this air, if when it starts from the Tibetan plateau and it moves towards the low pressure, okay, because in India there is a low pressure area, okay, and so the winds they come from the ocean, Indian Ocean, they come to India. But before that, winds from India, they are very dry, they don't have any kind of moisture, because as they are flying or moving from the land, they don't have any kind of moisture, so they don't have rain. If it goes on, then India might be a dry region, but still India is not arid. What's the reason behind it? Let's try to understand that, and we'll also understand what is Coriolis force. Okay, Coriolis force, it's an apparent force caused by the Earth's rotation. The Coriolis force is responsible for deflecting winds towards the right in the northern hemisphere and towards the left in southern hemisphere. This is also known as Farrell's law. How it exactly does, let's see. First of all, Coriolis force, it's a term which is existed on the earth. So we'll take a shape. Okay, so on here you will see that, just imagine that this is the earth and this is A point and this is B point. Okay, yeah, this is A, this is B. Okay, now when the earth starts rotation, when this rotation is going on, you will understand one thing, that in 2 seconds this that is A, isn't it? So this is moving and it has to cover this much distance in 2 seconds. Okay, and this, it has to cover this much distance, means almost same distance they are covering, isn't it? This also and this also. It means that if a person, if this B it is moving, then the point which is at the edge, it must be faster, isn't it? So now here we'll keep the earth. Now this is a green land, white colored, and on that a person is standing. Okay, so as you know, this is covering the distance, same distance, and that B person, he is also covering the same distance. But the person who is standing on B, he has to cover maximum distance. Sorry, same distance they both have to cover, but the person who is standing at the B point, he is covering that same distance in same time. It means that the person who is standing at the B, he has to travel faster, isn't it? So same like that. What is the relation of this with the our Coriolis force? Let's try to understand. Here you can see the equator, middle line, middle arrows. Okay, they are moving faster. Okay, and the arrows which are to the north side or south side, yeah, uh, so here you can see this, they are moving slowly and this is moving fast. So when the clouds, they get deflected from here and they go to northward, so as they already have got speed here, they will contain that speed same when they will go to north side. Okay, they will not move back, they will not get adjusted in the slow speed. And if from north side, with that slow speed, if they are moving to the right side, when they will come down towards equator, with that same speed they will come to equator. It means that we'll understand one thing here, that when the clouds they are coming from north side or from south side towards the equator, then they will lag behind. Why? Because already these 2 points, south side and north side, they are running slowly. So that same speed they carry with them, and when they come to equator, they are lagging behind. Okay, so they get deflected to left side or right side. Okay, but they don't go straight. Don't go straight. That is the point here. They get deflected because of this Coriolis force. And same, when the clouds they are traveling from equator towards the northern area or southern area, they will not go back. They will not go back. They will go straight. Okay, means they will not go straight. They will get deflected towards the speed. They will get deflected where those arrows are moving. Okay, that is right side or left side. Clear? So in this way, Coriolis force will understand by this. Now here, the Coriolis force is responsible for deflecting winds towards the right in the northern hemisphere. Here you can see how they move towards the right. You can see the arrows. Okay, and from equator when they are going southward towards the left in the southern hemisphere. Okay, so in this way, Coriolis force affect all this activity of the winds. So that is also one of the reason. Now if there is a low pressure, so it will receive the winds from both sides. So from equator, if it comes up, it will go right side, and from up north side it will go down, then it will get deflected to left. So this rotation is going on. Okay, so in this way you can see north side the winds they are moving anti-clockwise. Now let's talk about the southern part. Again, low pressure is here, winds are coming there. One wind came from equator, so it get deflected to right, and one wind is going towards equator, so it get deflected to left. So again there is a rotation you can see. So in southern side you can see these winds they are moving anti-clockwise. Okay, so in this way, this is what about the Coriolis force. I hope you might have understood this. Okay, still if you have any question you can ask. Now next thing which affects the Indian monsoon, or we can say Indian climate, that is jet streams. Why they are called jet? Because they move faster. Very simple. Okay, these are narrow belt of high altitude. Okay, I mean high altitude means they move northward or southward. Okay, above 1200-meter westerly winds in the troposphere. Their speed varies from about 110 km per hour in summer to about 184 km hour in the winter. A number of separate jet streams have been identified. The most constant are the mid-latitude and the subtropical jet streams. Now how they are formed and how they move from one place to other place, that we will understand. So what are jet streams? In jet streams there are many types. Trade winds are also there, jet streams are also there. So these are layers of the earth. So as below you know very well, it's a troposphere, and above the last it is exosphere. So in troposphere, in a higher altitude they are formed. First layer from the bottom, troposphere, as you know very well. So winds they are just coming, and they are called jet streams. Sometimes speed 320 km per hour. Okay, 1,000 miles long they are. Okay, so such a speedy they are, that's why they cause many time disasters. Okay, so this flowing strip they just get bigger and bigger. So warm area, this movement from the Peru, this is a country. Okay, so here you can see such a big belt here, and when warm water is here, it just moves from here to this side, and wet water, that is cold water, just moves here. So when warm water is coming here, as you know, from warm water air just goes up, and because of this they create the clouds. Okay, so when these clouds are created, they go higher and higher, they create such a big streams which come to India or in many part of the country, many part of the world. Here you can observe which area, because why this is wet warm, because equator, low pressure high pressure, you know very well how they move from one place to other place. From high pressure to low pressure the winds flow. Okay, Now, how they are formed? Here you can see polar air mass, blue colored, and tropical air mass, that is in red colored. Now this belt, it is so much hot. Equator, that is tropical air mass. As it is so much hot, it creates the low pressure there, and because of this low pressure, it creates the wind. Okay, where the jet stream begins. These jet streams in equatorial region, they are formed because of this warm uh, region. Then least, most, and least means in equator it moves fast. So the jet streams, they are formed in equator because of sun rays when they fall on that. Then warm air is formed, because of that warm air clouds are formed, and in troposphere it is formed. Okay, so here you can see is the process, how they are getting deflected, how they are moving, and they just keep moving from one place to other place. Okay, so today we have discussed about a very big stuff. Okay, so here we will stop. This is what about the jet stream is. Okay, chalo, fine. So I hope till here everything is clear to you. Okay, chalo, fine. Now let's have a break. Thank you so much. Have a nice day.